So I'm going to do a lot of things on this quiz that are going to be more of, do you just understand some of the basics of things? Some of them are going to be easy to take a peek at. Some of them you're going to have to use your brain a little bit on. But I'm hoping on this first one with the logs, I'll come back to the x-intercept in a minute. Hopefully you remember, since it's been a little while now, that whenever we're doing a logarithm, the range is always negative infinity to infinity, and my domain is always going to have a direct relationship to any right or left shifts that I have. So since this particular log has a shift that's right 4, if I was asked for my vertical asymptote, I would know that my vertical asymptote was at x equals 4. Well, what's that mean? That's the exact same value where my domain would start. Could I look on the calculator and probably figure this out? Sure. But if I couldn't, that's something I could do without it to figure it out. Now the x-intercept I also could figure out without the calculator, but who wants to go through all that algebra? Now I could. But when I do get an opportunity to simplify things a little bit, if I were to go ahead and get that typed in, and look at my chart, now once I actually get it back to some normal numbers here, I'm looking for where my y value is 0. If the chart helps me to do that, great. If it doesn't, I'd have to stick the 0 in for y and use my exponentiating to be able to solve for that and get that done correctly. So like if I forgot on the calculator or it didn't work out well for me, I would plug in 0 for y. We just got done saying if I don't see a base number for that, I assume it's 10. So to exponentiate, I would use 10. 10 to the 0 power is 1 equals x minus 4, and then I'd add the 4 over. Okay? But do not write this as your answer, because if you did, that's a vertical asymptote, x equals 5. That's not what we want. We want a coordinate point, because that's what the intercept is. So whether it's algebraically or using the calculator, both of them get me to the same spot and are a fine way to get the answer. For this next part, rewriting into logarithmic or exponential form, most of you are good at going this to an exponent because it's base, power, number. Don't need to solve it. Just rewrite it. The place a few of you have struggled on the last part that we did was going the opposite way. But again, use this one as your example then. Sit there and go, okay, so it's log, let's see, the little number was my base, okay, so here. And the exponent was the answer part, okay. 7 to the third equals y. Okay, I've got the log version. But again, no answers up here. We're just rewriting it. We're just making it look a little bit different. So all I want to do on that part is that. Now evaluate, that's a different deal. And yes, I know some of you are going to say, I can just use change of base on this. But I'd really prefer that when you get to a problem like this, you either do one of two things. You either put in the equals x and say, okay, 4 to what power equals 16? Well, 2, okay, and that's the answer. Or, and basically I know it's the same thing, you can look at this and say, okay, I've got a log of base 4. I want what's here to have a base of 4. 4 to what power is 16? 2. And my inverses, 4 and log base 4, cancel. And I get the answer. Either one of those is perfectly acceptable. I really don't care which one you would use, but I really do want you to be able to do some of those things because it can come in handy. Same thing here. 3 to what power is 81? And if you're not sure, play with it a little bit because they're going to be whole numbers. 3 to the 4th power is 81. And work it that way. The last two are meant to make you think a little bit. And we've talked about these before. If you're going from a whole number to a fraction, or a fraction to a whole number, your solution's going to have a negative because you need a reciprocal. You need to flip it. 2 to what power gets me to 4? 2. But 2 to the second power is 4. I want 1/4. To flip it, I need a negative exponent. And that works both directions. Every time. And then this one's just seeing if you're paying attention. 9 to what power equals 1? Anything to the 0 power equals 1. Okay? But here again, I'm evaluating. So I have to come up with a number. Got to have a number for an answer. Find the inverse. Again, switch x and y. Solve for y. Well, to solve for y, I've got to get my log base 5 out of there. How do I do that? I exponentiate with that base number. But again, exponentiate, base exponent. This is not y equals 5x. It's 5 to the x power. And that's a detail I'll watch for. Because if you just write 5x, I'm going to circle it, move it up to where it should be an exponent, probably ding you for a half. So just be cautious that when you're doing that, you make it an exponent. Expanding, remember with expand, multiply becomes add, divide becomes subtract, exponents become coefficients, and in that order. So here I see a couple of multiplications. So all I have to do is every time there's a multiplication, there's a product, I just put a plus in. 2 times w times z, 2 plus w plus z. And I need my log with each of those. And that's all I can do. Now, some of you have asked before, when there's multiply and divide, does it matter which one I do first? And it doesn't really. I typically, on ones like this, tend to do the divide part first. But if you don't, it wouldn't mess things up. So like here, if I did the divide part first, divide becomes subtract. But then I'd have to remember and go back and say, oh yeah, that's still a product. So I can still break that part up into its 2 pieces. No exponents this time, no more products, no more other division parts, and we're good. And then, of course, we got to get one in here that kind of hits on everything. Now here, we do always want to do the exponents last. So I look and I'm like, okay, that's a multiply, which means those 2 add. But then I'm dividing, which is subtract, the w to the 4th. And then when I'm trying to expand, my exponents become coefficients. And once I hit that last step in dealing with all those exponents, I'm good to go. I'm done. And the nice thing is, if you do understand expand or condense, you can just use those examples to help you do the other one. Except when we're doing condensing, everything goes from the bottom up. We did exponents last when we were expanding. Now when we're condensing, we're going to do those first. So if I see a coefficient, that's coming back up here before I do anything else. And once I get that set, plus becomes multiply. So y squared times 4 is 4y squared, and I'm back to a single expression, or a single term. But the rules are the same. It just depends on what direction you're going in. Tricky thing on 13, don't take the negative with the 7. Because that minus, we know, means divide. If I take the negative with it, that becomes plus, and then I'm multiplying, and I don't want that. So only take the number, leave whatever sign is there. And we just got done saying that minuses divide. So I turn that into a division, and I'm set. And again, that's always going to be the same on these. It's like anything else. The more practice you get, the easier it becomes. Well, what happens if instead of a variable I get a number and I can actually simplify it? You should actually. So like 4 to the 1/2, okay, square root of 4 is 2. 2 to the 5th power is 32. And now I'm just going to work this from left to right. Because I see the plus, which will become multiply, and the minus, which will become divide. So I've got the natural log of 2 times 32, which is 64, divided by 7. And I just assume you'll leave it in the fractional form. If you want to go to a decimal, I don't suppose it hurts anything, but typically we would just leave that in its fractional form, like that, when we're trying to condense it. But that basically covers all of those too, as far as going both directions with those. A favorite question from the last quiz comes up next. When looking at the function 16 times 1/4 to the negative x, is it growth or decay? Okay, you need to do more than just say growth. It has a negative exponent. Or I'll do what I did to a lot of you last time. I'll say but, and I'll throw the opposite number in and say, ooh, but that's decay, so no. So I agree that the negative exponent does cause it, but it's what the cause is that you need to explain a little bit more. And I don't care if you even do something like saying 1/4 to the negative x becomes 4 over 1 to the x, because we know that 4 would be growth. Okay. Or something to the effect of the negative exponent causes the base to act like it's reciprocal. Because now my base, instead of being 1/4, is going to act as though it's 4 because of the negative exponent. Again, number example, wordy example, I'm happy with either. As long as it's more than just the negative exponent causes it. Because that's kind of right, but it's kind of not necessarily. You'll also notice I went back and reviewed. I'm not just graphing on the logs, I'm also graphing on growth and decay because I want you to see the relationship that they have. We talked about them being inverses, but we don't get to see that a lot. So I'm actually going to start over here on 17. What are my two shifts on 17? Okay, so right 2 and up 1. When we're dealing with logs, it's the right or left shifts that we care about, because if I move right 2, so does my domain. Range is never going to move. That's no big deal. I also know by that being at 2, that's where my vertical asymptote's going to be, because I'm going to be watching for that. Don't get sloppy and go through that. And for your points, I don't care, because I know some of you are more comfortable playing with the technology, which isn't a terrible thing. If you want to just type in and then look for where you get whole numbers like 3, 1, and you can kind of go and see if you get any others. Okay, 12, 2 is kind of off the graph here. But again, make sure that graph keeps going. It doesn't stop at this point, because a lot of you will just look at the calculator and your graph stops. And I'm like, no, your graph doesn't stop though. And it's that understanding that we need to have here. So I'll watch for that too. Because if your graph stops here at like 3, 1, yeah, I'm going to keep it going, then I'm going to take a half point. So what's the relationship with these? Well, I look like, okay, that's decay. It's going to be coming like this. My domain here is always going to be the same. My range for growth and decay always changes on an up or a down shift. If it goes down, my range goes down with it. And we never really drew asymptotes when we were doing growth and decay, but I could to try and keep myself out of trouble. And again, if you just want to use a couple of points from the calculator with this, bless you. There's nothing wrong with that. Let's see if we can get a couple of points that are kind of nice here. If we can't, oh, we do. Oh, we got all sorts of them. Okay. So -3, 4, -2, 0, and -2. And again, it keeps going. But again, the thing here to notice is the relationships. Domain's always -infinity. Oh, range is. Again, it's just a flip. It's a reciprocal. Right shifts, up and down shifts. Make my domain and range. So I could get this information even without even graphing it. But we like being able to graph it anyway. So again, stuff from the past will show up. Also from the past, number 18. What are the transformations? What are the shifts? Keep this simple. In the exponent, it's just like in log when it's in the parentheses. This is my left and right shift. In this case, it's left 2. Whatever value's on the end, okay, not in parentheses, not in the exponent, is my up and down shift. That's all I want. Keep it simple, keep it simple, keep it simple. You'll be given formulas to use on the story problems. Use those. Don't make up one of your own. Scientist estimates a specimen begins with 1,000 bacteria. Okay. If the specimen grows plus by 12%, be careful that you go to a decimal. Every minute, write the equation that represents the bacteria's growth. Okay, they're not going to tell me how much time. But they want me to tell them when it's going to make it up to 1,800. Okay. I don't want to guess and check. That would take too long. So I'm going to go ahead and type this in to my graphing function using x as my exponent. And then I'm basically going to scroll down until I see something over 1,800. And we've talked before about how you might want to explain this. It's happening somewhere between year 5 and 6. So I'm always a fan of writing the in-between number, but if you want to say a year, always go to the upper, because if you say 5, well, we're not to 1,800 yet. So sometime during year 6 is when we would end up at that value. Okay. Same type of idea working on 20 here. Suppose you invest your birthday money. Notice they didn't say how much. So I'm going to create a value. I'm going to give myself $100 here. So 100, 1 plus my rate. Don't use 0.3. That'd be 30%. That'd be awesome, but it's not happening. Compounded monthly. The word after is going to be the key. Monthly happens 12 times in a year. So there's my N. And then how long, we don't know what T is, will it take for your money to double? If I started with 100, I'm waiting until it gets to 200. But that's the Y value that I'm looking for in the chart. This doesn't go into my equation. This is what I'm going to type in the calculator. So I turn it on and I say, okay. And definitely, since you have more than just x in your exponent, make sure you're using parentheses, because otherwise you're going to get something completely different. What's inside the parentheses is not a big deal, but getting those for my exponent, very big deal. And we just start scrolling down until we hit the magical, in my case, 200. So it looks like it's going to take somewhere between 23 and 24 years. And again, if you're going to go with only 1 year, always go with the bigger one. But again, the formulas will be there. You just have to understand what goes where. And things like compounded, it could be daily, monthly, weekly, yearly, I don't know. I could put all sorts of things in there. Solve the equations for x. If necessary, round to the nearest hundredth. I need to get to x. It's in an exponent. So how am I going to get rid of this 5 and it's not divide? Ooh, now you're thinking ahead. You're knowing how to get to the answer already. So, well, you're close. I got a couple of options here. What's one thing I could do? 5 to what power is 25? 2. But I don't want this to be 25. I want it to be 1 over 25. Negative 2. If that doesn't click for you right away, you always could take a problem like that and use my log of base 5 to get that. So what I would do in this case, if I was going to use a log, is I'd say, okay, change a base. So I'd have the log of 1/25 divided by the log of 5. Okay, get the same thing. So whichever you're more comfortable with, you absolutely can use. You can use an inverse or you can just use your brain. I don't care. Here, I got to have a same base. I can't take 9 to some power to get to 27. So I'm going to turn these both into bases of 3. 3 squared is 9. 3 cubed is 27. And we said before, basically what's going to happen here is those bases, once they're the same, are going to leave me. And I'm going to be left with an Algebra 1 problem where I just multiply the exponents together on each side. And again, since we've been out of Algebra 1 for a while, I'm going to go ahead and just kind of work this one quickly. Fractions are absolutely legal. Don't think that they aren't. So that's another option I have for solving. 2 to the x equals 64. Play with some numbers. Find out that 2 to the 6th is 64. Here, just knowing how to get to my exponential. Base, power, answer. Quadratic means I'm getting 2 answers. So when you do the square root, don't forget. I threw a couple of easy ones in on 25. Log 2 and base 2 cancel each other out. We wish they were all that simple. 8 to the log 8, cancel. It's almost like giving you free points. And then the last two, just a quick reminder, if they're the same base on both sides, and they are, base 7, base 8, basically you just pretend they're not there. The only thing that I have seen cause people issues on this particular part of the quiz is when they don't take the time to think about if a particular value could cause an issue. Okay, 13 thirds, 4.333333333. All you've got to do is make sure that doesn't cause one of your logs to become negative. Well, that's under 6, so that's good. 4 times, that's good too. Okay, so I know that one works. Here, you're like, oh man, I gotta factor this? Yep, everything to the x squared side. I won't put a nasty one in there though. And what gets kind of tricky on this is going to be, you want to make sure, I can't just assume that because I get a negative value for x that it's not going to work. Because remember, it doesn't make the log negative. If I plug negative 3 in here with parentheses, I get 9. 2 times 3 is negative 6, so 9 minus 6 is 3. That's still positive. 4 times negative 3 is negative 12, plus 15 is still positive. That one's going to be okay. And with it being a positive 5, that's going to be okay here too, I believe. Yes. So you can get two answers that work. This